sequences. There are different kinds and types of sequences. We've got arithmetic sequences, and we also have quadratic sequences. So these are the main sequences that we'll be using for our syllabus, otherwise there are many different kinds. There are so many examples of types of sequences. Now, examples, there are some known sequences. Examples like square numbers, a sequence of square numbers. A sequence of square numbers which include 1, 4, 9, 16, 25, and so on. And then we can also have a sequence of cubic numbers which also includes 1, 8, 27, 64, 125, and so on, so forth. You also have a sequence of triangular numbers. You also have a sequence of Fibonacci numbers. So there are quite a lot. Now, our syllabus requires us to know or to cover two objectives. The first objective, it is to know what you call the term rule. And of course, you also have what you call the n-term formula. So, mainly, starting with the arithmetic sequences. So, with regards to the arithmetic sequences, the word arithmetic has to do with addition or subtraction. So that's what we mean by arithmetic. So this basically means you'll be having cases where the sequence, or to get the next number or the next term in the sequence, you'll either add a common term or subtract a common term, which is why we will normally have an n-term formula where you have a general formula that you can always use. Now, let's say we're given this particular sequence. The first term is 1, the second term is 3, we have 5, we've got 7, we've got 9. And then normally they'll ask you to, what's the next 3 terms in this particular sequence? So 1, 3, 5, 7, 9. What's the next 3 terms?
11, 13, 15.
11, 13, and 15. 13 and 15. Now the question would be, state the term rule. So when they say state the term rule, Basho would say, what did you do to move from the previous number to the next one? So when they
Add 2.
So you add 2, and the answer will be add 2. Now, what if we say find the n-term formula? What is the n-term formula? And Bapinze after this, they can even ask you to find the 30th term. So what's the 30th term? So you will need the n-term formula for you to be able to find the term, the 30th term. And this n-term formula, the general formula of it is Tn is equals to A plus n minus 1 d. Now, of course, we need to explain what the first term, what the Term number means what the value of n stands for and the value of d as well. So Tn stands for the term number. So Tn is the term number. And then A is the first term in that particular sequence, first term. And then N is the number term. And then D is the common difference. Common difference. So going back to our example of this particular sequence, you will notice that to move from 1 to 3, we add 2, as we have noted. 3 to 5, you add 2. 5 to 7, you add 2. 7 to 9, you add 2, and so on. So this basically means the common difference is positive 2. And the value of A is the first term. So the value of A will be equivalent to 1. So this means in our n-term formula, we will substitute, so Tn is equal to 1 plus n minus 1, and then multiplied by 2. The reason I'm writing positive 2 is just that it is positive 2. Otherwise, it's the same as just writing 2. Because sometimes you can have a negative value. I will also demonstrate that example. So what this means is that you need to multiply. This is a single bracket. Even if you can put the d on the other side, still the same as having the d on this side. So this means it will be Tn is equals to 1 plus 2n minus 2. And then collect like terms. So 1 minus 2 is what?
1 minus 2.
1 minus 2, negative 1. So this means the n-term formula, normally the formula lesina to get from the previous term to the next one is this one, or this is the rule in terms of the formula. Now the difference between the term rule and the n-term formula, we'll see the rule is still from the previous to the next in day. It is advantage of the term rule which angeke isitshele asikhona ukuthola the 20th term or even the 100th term, because plus 2 plus 2 plus 2 plus 2, so finally the term is 100. So the advantage of this is that I will just put 30 or even 100 as the term number, because that would mean the term is 100. So that's why I know in the term formula would be advantages for us. So remember I did mention Butsi, that's about to define the 30th term. How would you solve this? So this would mean the term is 30. Lagna n corner, you will substitute 30. So which means the term yes 30 is equivalent to 59. So this is how we use the n-term formula to find to find any term number. So number is 100, number is 30. Now, let me show another example in which we will have the term rule where we will need to subtract. So let's say our sequence now, say it's inyalo 7 4 1 -2 -3 what would be the next three terms? maybe let's say, okay, this is negative 5, so that it continues. So what will be the next step?
Negative 8.
Negative 8, okay? Negative 8 followed by
Negative 11.
negative 11 followed by
Negative 14.
negative 14. Exactly. So how did you get these answers? In other words, what is the term rule?
Subtract 3.
Subtract 3. Exactly. So subtract 3. That's the term rule. Now, how did you, okay, maybe let me say, how can we find the 50th term? What is the 50th term? In other words, the term is 50. So again, you will notice that for you to get the 50th term, you don't really need to subtract 3 until you get to the 5th value of the sequence. So what you can do, apply the same procedure that we did in our earlier example. So we note that to get to the next term, you simply subtract 3. So it is a common term. So this is what you will do. You will have to recall the sequence. You will have to recall the general formula for arithmetic sequences. I should mention that this only applies to arithmetic sequences. It will not apply in a quadratic sequence. So hence, you will have to first note what type of sequence you are given. So the first term, you'll notice that it is 7, and then n minus 1. The common difference now is negative 3. And then multiply in 7 plus negative 3n plus 3. Because negative 3 times negative 1 is positive 3, and negative 3 times n is negative 3. So basically, this would be 10 minus 3n. So the n-term expression is 10 minus 3n. For the n-term formula, which would be in an equation form, would be Tn is equals to 10 minus 3n. Now the question said, what would be the 50th term? So what we'll do, having found our n-term formula, Tn is equals to 10 minus 3n. So the 50th term, we will have to substitute 50 in the place of n. So this will give us 10 minus 150, which will be negative 140. Exactly. So this is how we do arithmetic sequences. Now the next one is from a quadratic. Yeah, because my quadratics, they are extended. Otherwise, yeah, they are extended. Because for now you use a different formula, which is a bit.
But I'm saying, the temple can be even different, and then subtractually based, there's a common difference.
But maybe let me demonstrate it so that I can see if this is how you know it. For the benefit of those who are in the extended curriculum. So ideally, the first thing that you should note is that a quadratic sequence is of the form A. So the general formula. So the general formula for the quadratic sequence will be Tn is equals to an squared plus bn plus c. So this is the quadratic sequence formula. Now, there are three important expressions that you need to remember, and I'll show what they are equated to. Now, this will benefit iron. So, the first term in the original sequence, so the first term, original sequence, is equivalent to A plus B plus C. And then the second difference, maybe before that, let me just find what you call the first difference. So the first difference is equivalent to 3A plus B. So if you like, I can even show you where this comes from. But these are the expressions that you would have to recall in order to solve a quadratic sequence. Now, the second difference, which is also called a common difference, so the second difference, which is the common difference, will be equivalent to 2A. So 1, 2, 3 expressions that are important for you to remember. And once you recall all these, it will be easy to get the value. Now, let me give you an example of a quadratic sequence, and then we'll solve it using these expressions. So let's say this particular quadratic sequence is, for instance, mass square numbers are one perfect example of quadratic sequences. So notice this is now 1, see now 4, it's now 9, it's now 16, it's now 25. So obviously the next 3 will be, so we've got 1, 4, 9, 16, 25. What's the next term? After 25, it's a quadratic sequence. In other words, you notice good in our square numbers. 1 squared is 1, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared,
64.
Right. Now, of course, if you were asked to state the term rule, that's it. Because this is what you're going to be asked about core. But that was it. State the term rule. So the term rule would be square the previous number or square the given number. Square a natural number because it will not be multiplied by 2, just square the natural number. So square natural number. So because these are squares of natural numbers, because 1 squared is 1, 2 squared is 4. So just square natural numbers, that would be the rule. However, that extended, but now to state the n-term formula. N-term formula. Now remember, maybe let me erase the top part so that I can explicitly show this. So, since our sequence, I want you to note this so that you can be able to make the distinction between an arithmetic and a quadratic sequence. So now we're looking at the quadratic sequences. So quadratic sequences. So our sequence is 1, 4, 9, 16, 25, and maybe at least 36. So ideally, in our arithmetic sequences, as we have shown earlier, the first difference just gives you the common difference. But in this case, you see something interesting. So to move from 1 to 4, you notice that you add 3. From 4 to 9, you add 5, you add 7, you add 9, and then you add 11 to move from the previous to the next. So as you can see, this is why this is called the first difference. So this first difference is not common because they are different numbers. But as you continue, it's fine. So in other words, we are simply forming a new sequence of numbers. Then the difference between these will give us positive 2, positive 2, positive 2, positive 2, positive 2. So now in a second here, this is what you call a common difference. How are you taught? Or how will you solve this? Anyway, let me step out because I want to see if you truly grasp this. Okay, maybe I'm keeping a class, then you will perhaps it will ring a bell or come back to mind. So that's all now. Once upon I will sit that so. Remember these 3 expressions that I've given you. Instead the first term in the original sequence, A plus B plus C. So meaning the first term in the original sequencing now one. Basically, the first term in the first difference will be equivalent to this one. So the first term in the first difference is equal to 3. So we need to solve this being 1. Then the second difference will be equivalent to this. In other words, these 3 expressions will help us to solve for A and solve for B and solve for C. After we solve for these 3 variables, then we will plug into this and then we will have our quadratic sequence. So you will notice that you cannot solve A plus B plus C because bang 3 are unknowns without having solved 3A na B. Now you can't solve 3A plus B without having solved 2A. Because now there are 2 unknowns, there are 3 unknowns, and there is 1 unknown. So the first thing to do, it is to solve now 2A. So 2A is equivalent to the second difference. Shows it's equal to 2. Then divide by 2, divide by 2. So the value of A is equal to 1. In other words, we have solved it for the value of A. So now that A is solved, we can then solve for B, which means starts 3A now plus B is equals to, notice, it's equivalent to the first term, first difference. So first term, first difference, now 3. So 3A plus B is equals to 3. So mobile 3A, A is 9. So we get 3 multiplied by 1 plus B is equals to 3. Therefore, 3 plus B is equals to 3. Subtract 3 both sides. So B is equals to 0. So we'll solve for the value of B. Now, we can then solve the final expression, which is A plus B plus C. and this is equivalent to the first term original sequence. So we have A plus B plus C equal to 1. Remember, if value A is 9, 1 plus if value B is 9, 0. So plus C is equals to 1. So obviously this is equivalent to 1 plus C is equals to 1. Then subtract 1 both sides. So C is equivalent to 0. So we have the value of A, we have the value of B, and we have the value of C. So we can substitute that in our arithmetic sequence n-term formula, or the general n-term formula. So since Tn is equals to an squared plus b squared plus c, where there is a, you are going to put 1. Where there is b, you are going to put 0. And also where there is c, you are going to put 0. So 1 times n squared is just n squared. And then any values, 0 squared is just 0. And then plus 0. So this is how we get rho Tn is equals to n squared. So this is the formula. Does it ring a bell? Okay, let me show you a second example. Perhaps this one will be much more clearer. And how we talk. I can't remember any formula for getting this. So again, I'm going to write a sequence, a quadratic sequence, and then we will solve it using the expressions. This one that I got in your book, I think in a 0, let's say about 3, the exercise 2.10. Yes. I think in I, yes, it's called this one. Yes.
3.
So we've got 3,
6,
6,
11,
11,
18,
18.
dash, dash, dash.
Now, usually what I find interesting with most learners will say, who are all about 10 plan 3? But then I said to find the intent form. Learn and show my chair. So we've got 3, we've got 6, we've got 11, we've got 18. What's the next one? You will notice that so allow we add what?
3,
3. So allow we add
5.
So allow we add. Those things Allah, let's add the 9 to get 20. To get I go 11. Then when you add 9, you're supposed to get 27. Then when you add 11, you're supposed to get 38. And when you add 13, you're supposed to get 40. 50, 51.
1 is.
So these are the values. Now the question is, how then, because this is the first part of the question. It will say complete by filling in the 3 missing values. Question B, the say it again, find the n-term formula, put the say the 30th term or the 50th term. So once you see this, this might be a quadratic sequence. So it's no longer an arithmetic. Then as a student just check Find the second difference. Lab 1, add 2, add 2. So because the second difference is the one that is common, it tells us who's the NR. It's a quadratic sequence. Then, remember the n-term general n-term formula for a quadratic sequence is Tn is equals to an squared plus bn plus c. Then the question is, how do we get the value of a? We get the value of a by saying 2a. So 2a is the second difference. Then 3a plus b will help us to get the value of b, and 3a plus b is the expression which is equivalent to the first term, first difference. And then of course, the last one will be a plus b plus c, which simply means is the first term in the original sequence. So, let's quantify this. So this means 2a is equivalent to 2, 3a plus b is equivalent to 3, exactly. First term, first difference. Then a plus b plus c is equivalent to 3 again, because we know 3 low will tell first term original sequence. So now that we have this, all we need to do is solve all these 3 equations and substitute the unknowns into the general formula or the general equation. So you notice that for you to get the last 2 equations solved, you need to solve the first one. So 2a is equals to 2, so divide by 2, a is equals to 1. Solved. Then now that you have a, you can solve 3a plus b, which is equals to 3. So in the place of a, we substitute 3, rather 1, so that we have 3 plus b is equals to 3. Subtract 3 both sides, so b is equals to 0. b is solved. Then lastly, a plus b plus c is equals to 3. So the value of a has been determined, it's 1. The value of b has been determined, is 0. So therefore, c will be determined because the equation will now be 1 plus c is equals to 3. So the unknown is c. Therefore, subtract 1 both sides. Then 3 minus 1 is equivalent to 2. So this is the last value that we have found. So having all 3 values, we will now substitute them into the original. Tn is equal to an squared plus bn plus c. So where there is a, we put 1, n squared. Where there is b, we put 0. And then where there is c, we put 2. So notice that any number or any value multiplied by 1 is that value. So it becomes n squared. Then any number multiplied by 0 is 0. So n times 0 is 0. And then of course, this will give us this. So therefore, the answer will be Tn is equals to n squared plus 2. So this is how we solve arithmetic sequences, rather quadratic sequences. Hence, the last question that would ask you would be, find the 30th term. So T30 will be, remember Tn is equals to an squared, or in fact, since we now have the n-term formula, Tn is equals to n squared plus 2. So where there is n, we put 30. So 30 squared is 30 times 30, which is 900. And then 900 plus 2 is 902. So this is how we get the 30th term. Now, of course, I should remind you, this is normally asked the data extended. Otherwise, this is the formula. So, which means your assignment would be to practice recalling this, practice recalling that, and practice recalling this, and that. Putting A plus B plus C is the first term, original sequence. 3A plus B is the first term, second difference. Then, first term, first difference. Because this is in the original sequence. So 3A plus B is the first term, first difference. Then 2A is the common term, second difference. Yeah. So that's how we do quadratic sequences. Unless, of course, there's a question, but this is mainly how. Maybe the last thing that they might ask you is cases where they form what you call mappettings. This is also still related. Mappettings where they'll show you a pattern of dots and then ask you to draw a missing pattern, then say those are mainly the applications. Otherwise, these are sequences. Otherwise, there's another.